Richie. So currently I am at the Escuela de Matemáticas right now. So I'm at the school. It's after hours. I'm supposed to close up, but I just decided to sit here and work on stuff. There must always be a Lich King. There must always be someone leading this at all times. Like I have to make sure. The voice actor gets his voice actor parts. The Richie gets his Richie parts. Matthias gets his Matthias parts. Everyone gets their money. Gotta make sure. And I have to make sure the math is being animated right. And you've been doing fucking fantastic. I don't know why you're worried about that email I sent earlier, dude. You may think that there's a finite amount of work. I assure you, there's a lot of animation that still needs to be done. A lot. Like this, my plan originally was to have by the end of this summer 10 lectures done, or 5 lectures at least. We only have just about to finish 2 lectures. So the most I'm praying for is 1 Harvard, 2 Stanford, or almost all 3 Stanford lectures. And there are entire textbooks. And we just gotta keep going, just gotta keep pushing at it. Finding the right animators, finding the right animation, the 3D artists, the 2D artists, just gotta keep on going, just gotta keep on pushing. You're saying yin and yang, you guys saying yin and yang? You know what? I am yin and yang power together. Forget the balance. I am pure energy. Pure café. Un café. Let's do this. So let's go over your part. That's my spiel. So we're up to this part. Therefore, the square of the average is less than or equal to the average of the squares. You just re-show you're finished with the proof, you just show the final step of the proof. That's it. You just show what you're trying to prove from your example 2. You just show your green thingy. That sounded weird. Just show your green thingy. Awesome. Okay, so next part is, let's see. The final example doesn't have a cue saying, or at least not one I can think of, but the symmetry is pretty sweet. So you can put a little pause here to show the symmetry. So let me show the symmetry. So right here, at the symmetry, at example 3. Just, you know how it works. Just like make it vertical like you've always been doing. Like making it pop up and make it vertical. Not vertical, horizontal. Like what you've been doing like for the last 2 examples. And there's actually secretly a 4th example. So we go here. Do you see this guy? So this guy is the actual equation here. I just made it out like this. When he says the expression, but the symmetry is pretty sweet, you're going to pause and just show the symmetry. Just show the symmetry, just show the path. Just some sort of way to emphasize that there's a path going on. Maybe by glowing, maybe by making each of them glow in order, maybe by making a line segment. Yeah, I leave it up to you. Okay, and then you're gonna do something, and you cannot do, and no homo, okay? No homo on this one. No homo. No. I'm just joking. I don't know. You can do whatever you want to do. I respect people of old mathematics. So this one, the next part says, but the symmetry is pretty sweet, and we show the symmetry. And just like in love, it is easier to see beauty than describe it. You can have Cauchy appear. You can have Cauchy Schwarz appear. Why I said no homo is because don't show Cauchy and Schwarz kissing. They cannot kiss or anything. But for example, you can have them like have little hearts or something looking at the equation, or do whatever you think captures love. I only know mathematics. I do not know love. Love is confusing. What is love? You know, what is love? It's just, you know, just don't hurt me. Don't hurt me. No more. Alright, so you know this part. Make the vectors appear. Jetta? Make the vectors appear. Do your thing. Yeah? Do your thing with the red. With the Cauchy Schwarz. Do your thing. Make the things collide together again. Like the colliding collect together. You've done this 100 times by now. Each thing colliding together. Oh wait, but this one's wrong. Okay, sorry. You make it first collide together here to form this. You keep on colliding, and then you collapse it to make these. Same idea for the next step. They say, oh, for the norms, you just read this, and then you simplify each square. Awesome. Then you simplify. Then you make all the squares. Then you use the squaring powers to simplify. Awesome. Share. So then for the next part, you show. Yeah, simplification powers. Where's the next part? Why is there a part like that up there? Yeah, the next part should be you apply Cauchy-Schwarz. Yep, then you apply Cauchy-Schwarz. Like you applied like 100 other times, you apply it. You do the exact same thing. And then when they say, oh, I switched these, that's why. Okay. So when you apply Cauchy-Schwarz, so let me move this up. They're going to say, so after you apply it, so let me actually read the script. He says this. He says this after during the script. He says, applying Cauchy-Schwarz, the absolute value is less than or... Okay, yeah. Is less than or equal to the product with the norms, but we can drop the absolute value since the AIs are positive. So this part, you're just going to go from here to here. Just make the little bars disappear. Alright, from here to here, make the bars disappear. Awesome. Good. And then the next part, you're going to square both sides. Just like you did before. There should be a little squaring both sides here. Just don't make them as ridiculously retardedly big as the ones here, because they're retardedly big. But I trust you to make it nicer than the okay, than the stuff I've been doing. Okay, so then you square it. It's gonna say square both sides. Oh, this part should be okay. Square both sides. So you square both sides. You square both sides, and you do what you did before. You distribute the little. Why did I forget the squares again? Oh, wait. Yeah, there should be a square here. There should definitely be a square. Okay, so there's... When you square both sides, there should be a square like here over here. There should be a square. Right, you square. Just like you squared last time as well. You distribute the 2. So remember, each of these should have a little 2 on top. Yeah, little 2. Totally good. So you square both sides and you distribute the square on the right. And that should give you this. Totally. Do the same trick you just did. There's a square. Yeah, Now you're at this point. After they say square both sides. And then the voice says, since both sides are non-negative, we can... Okay, we squared inequality. Notice that A1 up to A2 up to AN is the same as A2 plus A3 up to AN plus AN1. Thus, we can divide out by both sides, divide out by A2 plus A3 up to this guy. So just divide out. So just divide out both sides. So just highlight these are... So with the previous equation, highlight that they're the same, that this expression in the blue and this expression in the blue are the same. I trust you to come up with some way to highlight it. And then, because everything come up with so far has been brilliant. And then, just cross out one of these squares and this guy here, and then delete it. And then we're done. And then we're done. There's going to be no voice because then we're done with the proof. Because we are finito. We are finito. The very last line should be just what we're trying to prove. Last line should be just what we're trying to prove. No more parentheses, no more square. None of this guy. And we're done. Aha, we're done. Okay, hope that made sense, Mr. Richie, and I will see you later. Bye.